when you cut and put sodium solid particles in water, these solid particles of sodium, we call it sodium pellets. If you drop it in water, these sodium pellets will start moving about the surface of water. We refer to that as dart, D-A-R-T. The sodium will start darting about the surface of water and reaction will start. In a short while you will see something coming out, a gas. That gas is hydrogen gas. In the process, the sodium will start melting. Now we are going to write a balanced chemical equation for this reaction when sodium reacts with water. Come along, let's see what we do. Remember the first thing, write the correct chemical formulae of this reactant and the product that's going to be formed. So we go sodium, Na, it's a solid, I said that already, so we put a state of matter, and sodium naturally is written like this. Is that okay? Now it's reacting with water. Water is liquid. Now the product we are going to get is what? Let us look at what is going to form here, okay? Do you still remember that in water there is a radical in it? The radical in water is OH. The radical in water is what? OH negative. Water usually contains H positive, which is cation, and then OH negative, which is anion. When they attract and interchange their valences, it forms water. So, during the reaction, sodium will pick the OH negative part because sodium is positive. You remember from valency, sodium is positive. Now in water we have OH. OH is negative, so there will be this attraction. Opposite charges will attract. When that happens, we are going to get sodium hydroxide. Sodium hydroxide, in this case, will be in a form that we call aqueous. Aqueous is a chemical liquid. Is that okay? Refer to it as aqueous. Now, this is going to release hydrogen, like I said, because from this water it is OH that was taken by sodium. H is still there because OH, which is negative, plus H, which is positive, when they react, will give us H2O. So that hydrogen will be given off as a gas. I know that if hydrogen exists on its own, it exists as a diatomic substance. So that's going to be H2. Now let us check if this equation is balanced. For sodium, in the reactant it is 1. In the product you can see clearly that it is also what? 1. So sodium is balanced. Hydrogen. Hydrogen in the reactant is 2. In the product, watch out. In this sodium hydroxide, how many hydrogen do we have? Only 1. Then look at plus here, like you do normal mathematics. This is plus. You're going to add it to how many hydrogen here? 2. So if you do 1 hydrogen plus 2 hydrogens, you get 3 hydrogens. In the product, hydrogen is 3. In the reactant, hydrogen is what? 2. So hydrogen has a problem here, it's not balanced. Okay, oxygen. Yeah, oxygen is balanced. We have 1 atom in the reactant, 1 atom in the product. So what are we going to do? Let us balance the hydrogen, because that's where we have problem. Alright, balancing hydrogen. Balancing hydrogen. Now there was something I said, step number 5, when I gave the rules, the steps for balancing a chemical equation. Step 5, I stated that when you have a single gaseous element that is given off during chemical reaction, that element is treated independently. So look at what happened here. Hydrogen gas is given off separately. So we're going to treat this H2 separately. Let it be there. We wouldn't touch it. We'll come to this part. Now why we don't have to touch this is we can play around this H2 anyhow we want. Yeah, I can choose to add up any number of molecules. There's my choice to balance up anything. So I don't have problem here yet, since it is only H2 that I have, the only hydrogen. Let it be there. I will go to where I have hydrogen again, combined with other elements. Because whatever happens to hydrogen then may just affect something. I'll focus here and try to balance with this hydrogen. I'll balance the hydrogen here in sodium hydroxide in the product. I'll balance it with the hydrogen in water in the reactant. So let us do that. 1 molecule of hydrogen times 2 atoms, 1 times 2, will now give us equal to, in this case, I'm going to attach X here. You know, because hydrogen atom in the product, in this case, is lower. Are you following, right? It's lower than the hydrogen atom in the reactant. Remember, I have said we are keeping this aside. When we try balancing this and we have issues, we can now come here and do some, works. But for now, let's keep this aside yet, as if it doesn't exist there, and see if we can balance up this part. So X molecules times 1 atom of hydrogen, X times 1. So you see that 2 will be equal to X. This simply means that this number of molecules, the variable we put there, X, is equal to 2. So I'm going to rewrite this equation. Rewrite the equation. Now, if I'm rewriting the equation, I'm going to get sodium solid reacting with water, H2O, liquid. Now the product is sodium hydroxide. We got X to be equal to 2. So that's going to be 2 molecules of sodium hydroxide. This is aqueous. Then plus hydrogen gas, H2 gas. Now if you take a look at this, hydrogen is not balanced yet, because in the reactant we have 2 atoms of hydrogen now. In the product here in sodium hydroxide we have 2 times 1 atom of hydrogen, which will give us 2 atoms altogether. Then plus here we have 2 atoms as well too, because this is 1 times 2. So the 2 here plus the 2 here will give us 4 atoms of hydrogen in the reactant. But in the product, that's in the product rather, okay, 4 atoms of hydrogen in the product. But in the reactant we have 2 atoms. So we can easily balance up. But let us check for that of sodium first and see an oxygen. Because we have problem now, sodium is 2 here, oxygen is 2 in the product. But in the reactant, they are both 1, 1. So let us balance up for sodium and possibly for oxygen first, before we start talking about hydrogen again, if necessary. Balancing sodium. So the number of sodium in the product here is 2, but in the reactant it is 1. So the atomicity in the reactant is lower. I'll come here and then put an unknown. Okay, let's use Y. We've used X before. Let's use Y. So Y times 1 atom here will now be equal to 2 molecules times 1 atom of sodium here, which is 2 times 1. If you work on this, the value of Y is going to be equal to 2. So I will rewrite. I'll still rewrite the equation. Rewrite the equation. So if I'm writing the equation, Y is 2 now, so I'll put 2 sodium, 2 molecules of sodium is solid, plus H2O liquid. So this is going to give us 2 molecules of sodium hydroxide, aqueous, plus H2 gas. Sodium is now balanced. 2 atoms in the reactant, 2 atoms in the product. We are left with oxygen and hydrogen still. But like I said, let's work with oxygen first. We've touched hydrogen before, so we'll leave hydrogen for now. If necessary, we'll come back to it later. So balancing oxygen, because oxygen is not balanced. Balancing oxygen, let's see what we get. In the reactant, oxygen is 1 molecule times 1, which is going to give us 1, but in the product, it is 2 times 1, which is 2. 2 molecules of this sodium hydroxide times 1 atom of oxygen. So in the product, oxygen is 2, in the reactant, oxygen is 1. So where do we add our variable? We'll add it to the reactant. Which variable would you like me to use? Okay, let us use A and C. I'll put A here. I'll put A. Okay, so this is going to give us, or should I change it to C so that it doesn't look like 9 to anyone? So let me put it C. So this is going to give us C times 1. That is C molecules of water times 1 atom of oxygen. That is going to give us 2 molecules of sodium hydroxide times 1 atom of oxygen, which is 2 times 1. Don't forget, the number of molecules affect all elements in the what? Compound. So C is now going to give us 2, because C times 1 is C. Equal to 2 times 1 here is 2. So I will now rewrite the equation. Rewrite the equation. Let's see what we're going to get. Rewriting the equation, you come over here, you have 2 molecules of sodium. 2 molecules of sodium is solid, reacting with C is equal to 2, so it's going to be 2 molecules of water, H2O, liquid. Now this gave us 2 molecules of sodium hydroxide, 2 molecules of sodium hydroxide. It's aqueous, then plus H2 gas. Now oxygen is balanced now. So sodium is balanced, oxygen is also balanced. Let's revisit hydrogen and see what happens. Hydrogen here is now 2 times 2. 2 molecules of the water times 2 atoms of hydrogen will give us 4 in the reactant. Then in the product, look at this side. 2 molecules of sodium hydroxide times 1 atom of hydrogen will give us 2 hydrogens here in sodium hydroxide. Then plus, how many hydrogen do we have here? 2. So 2 here plus 2 here will give us 4 atoms of hydrogen in the product, which is the same as 4 atoms of hydrogen in the reactant. So everything is now balanced. Okay, so let me write that. Balanced. Balanced. So you can see how we have been able to write chemical reaction equations and balance them. Now next class we'll see for other compounds where we deal with radicals more. Until then, remember, talk about the JAMB 41 Support Student Education Initiative Program. Invite your friends to contact us and enroll in this special class that is arranged to improve your background of science and mathematics.